Yes, this is currently in
Yeah,
my
she
room.
did careful. Just my everybody say. And she get bold voice.
She didn't attempt doing now.
Eh,
Are you ready? Or when are you leaving?
what time is it?
It's time, baby.
Till 12 a.m.
11:55 p.m. Ah, baby. Okay.
I still have long time. You tell me the question of you. Please, you can just do the first time.
Yeah, no, it's done.
Okay, have you started already?
Not much people are so. Good morning, everyone. Yes, yes. Nine. If you have any question, people, I want us to revise, or any topic you want us to revise. I think I'm looking for the slide I want to share, but I don't know whether you prefer us going through past question or we should just revise what was taught. Okay, let me see. I think maybe I should go back to the benzene that I taught. Do we have any question on the topics or any of the topics that was taught? So let's see if we can go through any of them. Or should I go back to the benzene?
Well, please, can you explain the amines class again? I actually don't understand the class.
Is the slide available here? I'm looking at the
No,
slide.
like lecturer did not send us the slides.
Oh, that's a problem now. Okay, like I think let me say something about amine. But I would have loved to use. Do you have any question that you really want us to tackle on that? Do you have any question that you really want us to tackle on that? I think it will make more sense.
It's mostly on the reactions now.
Okay.
Yes.
Because the slide, that amine slide is not with me here. I'm trying to get the slides. I'm trying to get the slides.
Oh.
I have alcohol, I have ethers, I have carboxylic acid, I have ether, I have phenols. These are the slides I have. Are you okay with alcohols?
Yeah, yes, ma'am.
Yes, ma'am.
You okay with carbonate compounds?
No, ma'am.
Yes.
Can we do carbonate?
Yeah, my carbonate.
You can do carbonate, right?
Mm.
Okay. Do you have any slide? Do you have the slide of carbonate?
No, ma'am.
Okay, let me
send us slide.
Okay, let me download.
Let
me download the carbonate slide and
please, Mike, you also have the one. Please, Mike, you also have the one on acute alides. Please, we would really appreciate if you can send it to.
Okay, I will speak with the coordinator and ask him permission to send slide. Okay. Okay. So now, when we are talking about, let's start discussing about carbonate before I convert the slides and share with you. Now, when you talk about carbonate compounds, you talk about compounds that are two that like they're isomers. So it talk about compounds of aldehyde and ketone. Why are they called carbonyl? Because of the functional group they have in common. That's why they're called carbonyl compounds. So these compounds are as a result of reaction from alcohol. That's why, now if you can see in your class, alcohol was treated before carbonyl. So now it's as a result of oxidation reaction of alcohol.
Mr. Victory, are you with us?
Something is happening. Okay, so let's unmute so that it can be fine. So it's as a result of oxidation reactions of alcohol. Now, primary alcohol will always oxidize to give you carboxylic acid. But if they want to oxidize, the initial oxidation of primary alcohol gives you aldehyde. But depending on the reagent you're going to use, this aldehyde can undergo further oxidation to give you carboxylic acid. Meaning that if you have a question, that said, please let's mute ourselves.
They've not
If you have a
yes, ma'am.
mute yourself, please. Mute yourself, okay? So if you have a question that is using oxidizing agent like permanganate, chromic acid, and it is primary alcohol, the appropriate answer there is carboxylic acid. Whenever you're doing oxidation of primary alcohol, it is carboxylic acid, except you're using limited oxidizing agents. So let me share the slides. Let me share the slide now. So, but all secondary alcohols will give you ketone. So let's work with the slide now. So, like I said, carbonyl compound, they have this in common. This is a carbonyl functional group. Like I said, so we have two types. We have aldehyde and ketone. If you look at the structure, you realize that aldehyde has terminal hydrogen, while ketone does not have terminal hydrogen. That is why aldehyde can further be oxidized to form carboxylic acid, while ketone cannot be further oxidized. So that's one of the difference between aldehyde and ketone. Aldehyde can be oxidized, ketone cannot be oxidized because there is no terminal hydrogen. So primary alcohol gives you aldehyde and carboxylic acid, while secondary alcohol gives you ketone. Like I said, their difference is the terminal hydrogen and methyl of aldehyde and ketone respectively. Then whenever you want to name this compound, you consider just like the way you name any other organic compound. You are going to give the functional group a priority, meaning that in my aldehyde, the carbon that bears a carbonyl will be carbon number 1. While in my ketone, because ketone is not a terminal hydrogen, so the terminal is methyl. So I'm going to follow the route that will give that carbonyl functional group the minimal number. So I'm not going to start my naming giving the carbonyl carbon number 1, but I'm going to follow either left or right. I'll make sure that carbonyl is going to have the minimal number on the continuous carbon chain. So the naming should not be issued with you. So let's go to the things that you need to know. So the reactions are always oxidation reactions. So this is what happens in industry. So using water gas, carbon and hydrogen. But that is industrial. When methanol is oxidized, you're going to get, can't you see, this is methanol. When you look at it, the way the structure goes, this is not ketone. Remember, it has 2 hydrogens. So it will be HCHO. This is methanol. Okay. Then if it's ethanol, it gives you ethanol. That is the one we are most interested in. We are dealing with oxidation using the common oxidizing agent, which are permanganate and chromic acid too. Then whenever at times you can see now this chromic acid, these are just less. You can see where primary alcohol gives you aldehyde, while secondary gives you ketone. Tertiary alcohol is stable to oxidation. Why? Now, if you go back to alcohol, you realize that primary alcohol have 2 hydrogen. The carbon that bears hydroxy group is going to have 2 hydrogen. Secondary alcohol, the carbon that bears the hydroxy group is going to have 1 hydrogen. Tertiary alcohol does not have any hydrogen. That's why it's stable to oxidation. Okay, and that because primary alcohol have 2 hydrogen, it can undergo subsequent oxidation apart from aldehyde to give you carboxylic acid. So whenever you are in the exam hall and what you're giving you is this chromic acid or potassium chromate in sulfuric acid, the appropriate answer to this is carboxylic acid. You're going to get to the level where you're going to know that this oxidation must give me aldehyde. We call it limited oxidation. When we get there, you'll see. Yeah. Now, whenever I want to oxidize my primary alcohol that I don't want it to further oxidize to carboxylic acid, I'm going to use pyridinium chlorochromate. We call it PCC in dichloromethane. So this PCC is going to give us limited oxidation of primary alcohol. It can never form carboxylic acid. It will only end in aldehyde. So make sure you understand this. So other reagents can give you carboxylic acid except PCC, pyridinium chlorochromate in dichloromethane. Now, this is another oxidation. If you look at the carbon that bears the hydroxy group, you know it's bearing 1 hydrogen, meaning that the alcohol is secondary. That's why it's going to form a ketone. So whenever you see a compound, look at that carbon that bears hydroxy group. How many hydrogen does it have? That will also give you idea of the compound that will be formed. So this is mechanism of the reaction. Because of your what you're dealing with is CBT. So nobody will expect you to do mechanism. Okay? So let's not dwell on that. Now, I can also form my carboxylic acid. I can also form my aldehyde or ketone using dry distillation of metal salt of carboxylic acids. So maybe the question might be, which of the following cannot be used in production of aldehyde in the lab? So remember, I can also use dry distillation of metal salt of carboxylic acid. In that case, the compound I'm going to form is aldehyde or ketone, depending on what I am using. Remember, if I'm using calcium salt of carboxylic acid alone, I'm going to form my aldehyde, my ketone. But if I'm using that with calcium formate, I'm going to form an aldehyde. So that is the difference between them. Now, I can also form this aldehyde or ketone using reduction of acid chloride. When you reduce acid chloride using lithium, aluminum, hydrogen tertiary butoxide, I'm going to form my aldehyde. So remember the formation of aldehyde. I can reduce my acid chloride. I can use dry salt of carboxylic acid. I can use my oxidation reaction. These are the methods I can use to produce my aldehyde. In this case, what we need to know is the reducing agents. The reducing agent is not the normal reducing agent, potassium or aluminum trihydride. This is another one that we are using. We are using lithium, aluminum, hydrogen tertiary butoxide. Just know this particular reducing agent in terms of acid chloride. That's all you need. Please note it. So industrial, this is industrial synthesis of aldehyde. So let's go to the properties of aldehyde. Now, in terms of reaction, because I want us to cover as much as possible. In terms of reaction, we are going to talk about nucleophilic addition reaction. We're going to talk about the condensation with derivative of ammonia, which is very important. We're going to talk about haloform reaction, talk about reduction reaction and oxidation. These things, these reactions of aldehyde is what you have to understand. So when you see them in question, remember you're dealing with CBT, you know how to go about the questions. Now, if you're talking about nucleophilic addition reaction, let's look at what it means. Now, what it means is that this is the mechanism. Whenever there is a nucleophilic addition, so I want to add a nucleophile. So it means that the carbonyl bond has to break. And when it breaks, it's going to give us positive species on carbon and negative, so the negative species on oxygen. So meaning that any other thing that is coming, I can break them into positive and negative and know how to form the products. Now, this is important so that I don't go and start cramming. So example, now if I want to deal with, if the question is addition of hydrogen cyanide, you're in an exam hall, you don't know how to go about that. Remember, for this carbonate to react, the CO bond must break, the pi bond. Remember, in reaction, it's only the pi bond that breaks. So when this pi bond that connects carbon and oxygen breaks, I'm going to have positive. So electrophilic center will be on carbon, while nucleophilic center will be on hydrogen. And look at what I want to add is hydrogen and cyanide. So if I want to divide them, hydrogen will be the positive and cyanide will be the negative. So it means that under the carbon, I'm going to have my cyanide. While under oxygen, I'm going to have my hydrogen. Okay? So that is why the second product is cyanide on carbon and oxygen having hydrogen. Just for you to understand how it's gotten. Then under hydrolysis, whenever you're forming carboxylic acid, you have to do hydrolysis. So hydrolysis can be either hydrogen ion or water in acid. Okay? So this is water in presence of HCl acid. It can be also water in sulfuric acid. So to form the carboxylic acid. So whenever you're seeing cyanide being hydrolyzed, you're going to form a carboxylic acid. So that is why the final product is carboxylic acid. Whenever a reaction of carbonyl is undergoing, the carbonyl CO bond must break. So we're going to have electrophilic and nucleophilic center. So anything coming in, you can also break them into electrophilic and nucleophilic. Remember, the electronegative atom or element is going to be draw the electron to itself. So that is why cyanide is going to be electronegative, while hydrogen is going to be electropositive. So unlike are going to attract to form the compound you're looking for. So please make sure you understand it. And if you don't understand, let me know. So look at the mechanism has been taught here. Like I said, you can see the cyanide going to carbon and the hydrogen going to oxygen. This compound is what they call cyanohydrin. Okay, another is addition of greener reagents. This is very, very important in CBT. Why is it important is for you to know how to form your primary alcohol, secondary alcohol, or tertiary alcohol using greener reagent and aldehyde or ketone. Okay. Now, whenever you were discussing this, the reaction has been discussed under method of preparation of alcohol. Aldehyde gives secondary alcohol, while ketone gives tertiary alcohol. Now, what I want you to know is that the only aldehyde that can give you primary alcohol is methanol. I repeat, the only aldehyde that will give you primary alcohol is methanol. Other aldehydes give you secondary alcohol. A ketone give you tertiary alcohol. So, which of the following can form primary alcohol? Not any other aldehyde except methanol. Methanol is HCHO. That is only one that can form primary. Other ones are forming secondary. And when you're talking about ketone, they're going to form tertiary alcohol. So this is the mechanism as being shown. But I will not stress on the mechanism. Just for you to know, my methanol gives primary alcohol, other aldehyde gives secondary alcohol, while ketone gives tertiary alcohol. Another thing you need to know is condensation reaction. When you talk about condensation reaction, you're talking about two things coming together to eliminate water. So that's why they say condensation causes cooling. That's what you observe in your AC. When the condensation happens, you see water coming out and the AC cooling. So that is the condensation reaction. Cooling. I'm in class. So now in this condensation reaction, we are talking about an aldehyde and ketone. Whenever they are reacting, this oxygen that connects to carbonyl will be removed with 2 hydrogen from your ammonia derivative. Remember, we're using ammonia derivative. Okay, so that is what happened in condensation with ammonia derivative. So if I'm using normal NH2, now what happened is that in my normal ammonia NH3, it means that what will happen is that oxygen will go with 2 of the hydrogen and the other one will condense and form the product. So whenever a reaction like that is given to you, which of the following is a product? What you need to do is that go and remove oxygen and 2 hydrogen from your ammonia derivative, then condense them together, meaning that the nitrogen is going to replace the oxygen in the carbonyl. So it should be C double bond nitrogen. So other ones will be the remaining hydrogen from ammonia or methyl that is being replaced by ammonia. You know, we have primary ammonia, we have primary amine, we have secondary amine. Okay, so depending on what you're adding to your carbonyl compounds. So what you need to do is that I'm eliminating water. That water, oxygen is from the carbonyl, hydrogen is from my ammonia derivative. So every other thing condenses by nitrogen replacing oxygen in the carbonyl. Then form your product. The essence of this revision is for you to know how to solve problem, because this course has already been taught. So this is an example. Now, another thing you need to know is that when I'm having hydroxylamine as my ammonia derivative, what is the product I'm expecting? I'm expecting oxime. So you must know when I'm expecting hydrazone is when I'm using hydrazine. So I also understand what is the formula for hydroxylamine. Because one thing is for you to know what is oxime, another thing is for you to know what is that hydroxylamine. Hydroxylamine is my ammonia in NH3. So one hydrogen is being replaced with hydroxy group, becomes hydroxylamine. Amine is NH2, then hydroxyl is being added to it. So whenever I have hydroxylamine as my ammonia derivative, I'm going to form oxime. Remember the formula for oxime. I will just remove 2 hydrogen from this hydroxylamine. They will go out with the oxygen from carbonyl as water. Then other ones condenses to form my oxime. So when I'm dealing with hydroxine, I form hydrazone. Okay. When I'm dealing with phenylhydrazine, I'll form my phenylhydrazine. The phenylhydrazine is what you also know as Brady reagent in the lab. You know the orange or yellow crystal that formed. This is what they call phenylhydrazone. So you have to know what is oxime, what is phenylhydrazine, and phenylhydrazone. So the normal method used to identify the presence of carbonyl compounds in the lab is phenylhydrazine, which is called Brady reagent. It changes to orange or yellow color. So at times some people call it orange, some call it yellow. So there must be, and this occurs for carbonyl, both aldehyde and ketone. So when you're in the lab and they gave you unknown compound, you don't know whether it's aldehyde or ketone. As long as it is for you to confirm that this is carbonyl, what I need to do first is to add my Brady reagent. If I add Brady reagent and I get either yellow or orange color, I know that this is carbonyl. Then I have to go further to know whether it is ketone or aldehyde. With the reactions we are going to talk in the subsequent slide. So phenylhydrazine, we have hydrazine, and we have hydroxylamine. Hydroxylamine will give you oxime. Phenylhydrazine will give you phenylhydrazone. Hydrazine will give you hydrazone. What is hydrazine? Look at the slide. For the essence is for you to understand, hydrazine is 2 amine together forms hydrazine. Okay, so you know how to form the hydrazone. because two hydrogen from one of the ammonia will go, and oxygen will also go, so others will condense. Okay. Then another one is that when I'm using semicarbazide is going to form semicarbazone. Semicarbazide is going to form semicarbazone. Also understand the formula of that semicarbazide. In this instance, all you need to know. Now, all of them are forming the ketone form of them. Hydrazone, phenylhydrazone, oxime, then semicarbazone. So understand these condensation reactions of carbonyl compound. Remember, is feasible in aldehyde and ketone. So when the question comes, the equation can be using aldehyde or using ketone. In this, so don't look at what you're not looking at whether it's terminal hydrogen or methyl at the end, at terminal methyl. So you're not looking at is the reaction with aldehyde or ketone, any of them, as long as it's a carbonyl. What you have to look at the functional group. Is it carbonyl functional group? So you go ahead and follow the method as we are talking about. Okay. Now, this carbonyl compound can also be hydrogenated. They can be hydrogenated. When it is being hydrogenated, we can use phosphorus pentachloride. Okay. This one, there will be no evolution of hydrogen chloride, meaning I'm going to have a dichloro compound. So the carbon, the oxygen is going to go. So I will have something like maybe phosphorus oxide being eliminated. Then at the end, I'm going to form a jam dichloroalkane, meaning that carbon is going to have 2 chlorine. Oxygen is going to go with phosphorus. So in this case, whenever you see carbonyl compound reacting with PCl5, what you're going to form is germinal dichloroalkane. So depending on the number of alkane, carbon there does not matter. What matters is as PCl5, okay, carbonyl compound, so I'm going to form a germinal. The carbon that bears a carbonyl is going to have 2 chlorine. That's the end. So in this, that's what you have to be looking at. For aldehyde or ketone, okay, reacting with phosphorus pentachloride. So then acidity of alpha hydrogen. Now, when you're talking about acidity, what I want to summarize for you here is that because of the presence of alpha hydrogen, what is alpha hydrogen? You know what is alpha carbon. If you understand what is alpha carbon, you understand what is alpha hydrogen. The carbon that is next to the carbon that bears a functional group is alpha hydrogen. So the hydrogen, the hydrogen of that carbon is alpha hydrogen. So alpha carbon has alpha hydrogen. The acidity, if you look at the acidity, you realize that in terms of being acidity, you understand that our aldehyde will have more than ketone. Remember, because of the terminal hydrogen, as I said. So another reaction we are talking about is Aldol condensation. Remember, I said condensation is 2 things coming together to eliminate water. Okay. But in Aldol condensation, we are using 2 aldehydes. We can have 2 aldehyde or 2 ketones. They'll condense together, and at the end, what is happening? Remember, in Aldol, there will be alpha carbon. Look at the alpha carbon. Is that carbon next to carbon that bears or carbonyl group? So this alpha carbon, we're going to take out the alpha hydrogen. Then when we take the alpha hydrogen, then that becomes a negative center. Remember, a nucleophilic center is one that is going to attack. That nucleophilic species we are going to generate from that reaction of abstracting alpha hydrogen is going to attack the carbonyl. So that's why we're going to form this product. So whenever you're having Aldol condensation, 2 aldehyde or ketone coming together, they're going to form either hydroxyl aldehyde or hydroxy ketone. Hydroxyl aldehyde or hydroxy ketone. The position of the hydroxyl depends on the number of carbon that is forming the react condensing. Okay, this particular Aldol reaction, you're going to see more of it when you get your 300 level. Well, okay, let's see. Okay, look at the mechanism. And the first stage is going to abstract the alpha hydrogen. Remember, hydrogen of the alpha carbon, and alpha carbon is a carbon next to the carbon that bears a functional group. So when I form that, I'm forming a carbonium ion, right? Anion this carbanion is what is going to attack because it's a nucleophilic center. Remember, when we are talking about cyanohydrin, we said when this carbonyl bond breaks, the carbon is going to have a positive center, while oxygen will have a negative center. Now, and remember in chemistry, unlike is going to attract. So this nucleophilic center is electron rich. So it's going to attack this electrophilic center of carbon. So that is why we have what we have on the slide. And under hydrolysis, we form hydroxyaldehyde. The same thing can happen in ketone. Ketone is what is condensing. So what you understand is that whatever we're having, either hydroxyaldehyde or hydroxyketone. So what you're going to give, if you're in an exam and they are giving you, count the number of carbon. If it's ethanol, you know you're going to have 3 hydroxy. But depending if it's prop. Now what you're going to do in quick one is going to generate your carbanion, and when you generate it, where is it attacking? Where that carbanion is attacking, the carbon, the position of that carbon gives you the position of the hydroxy group. So you know whether it's 2 hydroxy or 3 hydroxy, because that's one of the confusion you might see in the exam. It will tell you 2 hydroxy or 3 hydroxy. But if you don't understand how it's being formed, you can make the mistake. So whenever you understand where it's going to be attacked, hydrolysis is not an issue. Just do the reaction. When I'm using 2, I'm going to get 3 hydroxy. So whenever I'm using 3, I cannot get 3 hydroxy. So I would have wanted you to, on your own, go and try using propanol, okay, or propan-2-one. So when you use it, form it and see whether you're going to have the hydroxy of number 2 or number 3. Okay, do that so you get used to that. When you enter exam, remember CBT is time conscious. It's not a time you start writing the mechanism, where there are so many questions to answer. So when you prepare this like this, when you enter exam, you will not waste your time and you will not get stranded. So this is another adult condensation. We are using propanol. Remember ketone, the minimum number of ketone is carbon number 3, but aldehyde start from carbon number 1. Okay, in our ketone, we are using, this is 1 ketone. You can see this ketone, because we are using ketone, we can't just use 1 ketone, we have to use 2 ketone. The first and second are ketone. So the first one, the second one that was spread out is for us to generate our carbanion. Is the carbanion that we generate is that is going to do the attack. Please, whenever you want to do this, don't leave the structure in condensed form. Can do it so that you can spread it out so you can understand how things go. If you leave it the way it is on the slide, you will not understand what you're doing. So spread it out, draw the structure of the ketone. So whenever it's attacking, you know how you're going to do your attack and form your product. Remember, if I'm using ketone, I cannot form now. I'm going to form a ketone byproduct. Okay. Now, whenever you're talking about dehydration, I'm talking about removal of water. Okay, so when I'm removing water, I'm going to form unsaturated compound. So when I'm doing that, the reagent commonly uses sodium hydrogen sulfate. What I'm expecting is that I'm going to, the place of water, any place that I'm removing the water, the hydrogen and carbon are not coming from the same carbon. So hydroxy group is going to come from 1 carbon, then adjacent carbon is going to give you the hydrogen. Okay, as hydroxy group is breaking up because it's a good living group, hydrogen ion is breaking in, forming the double bond. So that's why we have butan-2-NL. Remember, it's a butanol already. So the hydration is removal of water. Where do we remove water? The carbon that bear the hydroxy group, and the next carbon is going to remove hydroxy group, and next carbon is going to release the hydrogen to give us a double bond. So that is the hydration. So classing condensation is another form of condensation. Look, please, I would have advised you to go and look for past questions, so that when these questions are being asked, you know how to tackle them in your CBT. You don't enter exam and you're seeing this for the first time. And I also want to use this medium to talk about the test. Test is coming up next week, Thursday, by this time next week. The test is going to be online, but the format of the online will be communicated to you. So prepare for this test. Make sure you lay your hands on past questions you understand. And if you have any question that is not clear, you can share on the platform so we can give you and guide you on the answer. It's very, very important to practice. So Claisen condensation reaction take place between an aldehyde without alpha hydrogen. Remember, the one of Aldol needs alpha hydrogen. The one of cleansings occur without alpha hydrogen. So that is what is different between the two of them. That's what we call them cross Aldol. Cross Aldol. So another name for cleansing is cross Aldol, where we don't need what? Alpha hydrogen. Okay. Now, if you look at benzaldehyde does not have alpha hydrogen. So it takes place between an aldehyde without alpha hydrogen. Meaning, now, where am I generating? Maybe I need to generate my carbanion. So if you look at that, my aldehyde does not have alpha hydrogen, but my ketone has alpha hydrogen. So I'm going to use my ketone to generate my carbanion. Then the carbanion from ketone is going to attack the electrophilic center of the aldehyde to form the product we're looking at. So what is the takeout here? My Claisen is cross Aldol, where one compound will have alpha, another one will not have. That's why they call it cross Aldol. Normal Aldol is both must have alpha hydrogen, but in cross Aldol, what will have and what will not have. So that is different between cross Aldol. So whenever you see a reaction and say which of this reaction is a cross Aldol, go and look at all the compounds that are there. The carbonyl, one must have alpha hydrogen and one must not have alpha hydrogen. Okay, so that's what they call them cross Aldol. And when you see the Aldol that is 2, and not both of them have alpha hydrogen, you know you're dealing with Aldol condensation, not cross. Cross is there must be absence of alpha hydrogen in one. So another reaction is Cannizarro. In this Cannizarro reaction is a characteristic of aldehyde which cannot undergo Aldol condensation, right? So they do not have alpha hydrogen atoms. So they are cross Aldol. If you look at it now, you can see that they undergo self-oxidation and self-reduction. In Aldol, we have 2 carbonyl or 2 ketone that must have alpha hydrogen. In cross Aldol, we have 1 aldehyde that does not have and ketone that have alpha hydrogen. Then, oh, this is carbonyl compound. Somebody said which topic is it? We are dealing with carbonyl compounds. So it means you've not read to this extent. Now, but in Cannizarro, remember we talk about cross Aldol, which is called cleansing. We talk about normal Aldol, then we talk about Cannizarro. So I'm trying to distinguish. So whenever I see the reaction, they gave you an equation, they'll tell you what's the name of the reaction, what you're going to look out for. If you see a 2 carbonyl compound that have alpha hydrogen, you know you're looking at Aldol reaction. And if you look at 2 carbonyl compound, one with alpha hydrogen, one without alpha hydrogen, you're looking at Cannizarro. You're looking at cleansing, which is cross Aldol. So when you look at 2 aldehyde that does not have alpha hydrogen, which is benzaldehyde, reacting, it is Cannizarro reaction. In this reaction, they undergo self-oxidation and self-reduction. The one of oxidation and reduction, now when oxidized, they're going to form carboxylic acid, right? Remember, primary alcohol oxidizes to aldehyde. So when it reduces, it forms alcohol. And when this aldehyde further oxidizes, it forms carboxylic acid. So in Cannizarro reaction, the same benzaldehyde, when it oxidizes, it's going to form carboxylic acid, which is the second structure. When it reduces, it's going to form what? The benzyl alcohol. So that is the first compound. So it's going to form benzyl alcohol and carboxylic acid, because the benzyl alcohol is a product of reduction. Carboxylic acid is a product of oxidation. So that is a product. Please go back to your past questions and look at this question, so you understand that I'm going to get alcohol and carboxylic acid, okay? Because they're undergoing self-oxidation and self-reduction. That is Cannizarro. So these are the mechanism. You don't need the mechanism. So then, when you are talking about cross Cannizarro, normal Cannizarro it must be 1 benzaldehyde, 2 molecules of this benzaldehyde. When I'm dealing with cross, it means that I can have aromatic aldehyde and aliphatic aldehyde. So remember those without alpha hydrogen. And remember I said that this methanol is only aldehyde that can form primary alcohol. So when it's undergoing cross Cannizarro, because one is aromatic, one is aliphatic. One is going to form the carboxylic acid, and one is going to form the alcohol. Now, in terms of carboxylic acid, after self-oxidation, is reacting with sodium hydroxide. That's why it's going to form a salt of the acid. So if sodium hydroxide is not there, you're going to form normal carboxylic acid, that is methanoic acid, because it's still the same self-oxidation and reduction. But now what is doing that are two kinds of aldehyde. One is aromatic aldehyde, other one is aliphatic aldehyde. This aldehyde must not have alpha hydrogen. So if you see a reaction that have two aldehydes without alpha hydrogen, the reaction is cross Cannizarro. And if you see a reaction that have two aldehydes that does not have alpha hydrogen and they're aromatic, you're forming Cannizarro reaction. And they're doing self-oxidation to form alcohol and carboxylic acid. Please, this is very important because that's one of the one of the things that comes out in the CBT. CBT is a click away. Whenever you click, either you're there or you're not there. Now, in my cross Cannizarro, I'm not going to the aromatic aldehyde cannot form the carboxylic acid. Remember, the carboxylic acid is coming from the aliphatic aldehyde, that is methanol. Okay. Then, how do I distinguish between aldehyde and ketone? Number one, the major method of distinguishing between them is oxidation reaction. Because aldehyde can be further oxidized to carboxylic acid, while ketone cannot be oxidized. Okay. Now, aldehyde can also be oxidized using mild oxidizing agents. Like everything is about oxidation, 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 oxidation. So everything about that is oxidation. Now, if you look at the oxidation reaction, remember if you're talking about filling solution, they are all oxidation reactions. Now look at the number one oxidation reaction. We are using permanganate or chromic acid. They are going to form carboxylic acid. Remember I said whenever we are using PCC in dichloromethane, it can never go further. It will end in aldehyde. That's for primary alcohol, forming aldehyde. Okay. So by oxidation, when I'm oxidizing my primary alcohol with permanganate or chromic acid in acid, I'm going to form carboxylic acid. But when my aldehyde is oxidizing, it's going to form carboxylic acid. But ketone cannot be oxidized because there's no hydrogen. Remember, oxidation is addition of hydrogen or removal of addition of oxygen or removal of hydrogen. In this case, we are adding oxygen. And remember, or removal of hydrogen. But in ketone, there is nothing to remove. So ketone is stable to oxidation. Okay. Now, this is the sort of make a ketone. You can see ketone cannot be oxidized. What happens? There is a cleavage of bond. It's difficult. So when you have the bond will cleave, it's going to cleave into two. So when you cleave into two, what are we having? We are going to have two acids, and there are no more. So that's why ketone with difficulty and is going to form break. The bond will cleave, but aldehyde is going to. Now, when ketone oxidizes, it cannot form ketone again. But when your aldehyde oxidizes, when you reduce it, it's going to form the original compound. That's why they say ketone is stable to oxidation. Now, another reaction is Tolles reagent. Tolles test or silver mirror test is very, very important. You're going to see it in the lab. You can use it to remember it's an oxidative reaction. So any compound that undergoes oxidation can react with toluenes and fillings. So in the lab, when you'll be doing practical, you're going to see that when I get my unknown compound that is carbonate compound, first thing I'm going to do is to add Brady reagent. When I add Brady reagent, everything will be either yellow or orange precipitate. So when I bring another sample, I said, okay, these are carbonate compound, which means it can either be aldehyde or ketone. So how do I say specifically this is aldehyde? Then I will bring a fresh sample without reagent and add my silver mirror reagent. When there is formation of silver mirror at the walls of the test tube, I'll say this is aldehyde. And when there's no reaction at all, as if I'm pouring water inside water, I know that this is ketone. So because silver mirror test is an oxidative reaction that can only go when in a compound that can undergo oxidation. So that's another means of distinguishing between my aldehyde and ketone. My aldehyde can be reactive with silver mineral, while ketone cannot. Okay, that be the deposition of silver at the neck of the test tubes. In the same manner, Fillings reagent is also an oxidative reagent. So anything that can undergo oxidation, carbonize that will undergo oxidation will be reactive with Fillings reagent. So when you gotten your carbonate compound, you want to distinguish the class, you can just take a fresh sample and add Fillings solution. If you add these Fillings reagents and you see a deposition of red precipitate or brown precipitate or brownish red precipitate, you know that this compound is an aldehyde. But when the color of the Fillings solution is still what you saw at the end of the reaction, you know this is what? Ketone. So these are the reactions that is important for you to use to distinguish between aldehyde and ketone in the lab. Like I said, oxidation of primary alcohol will give you aldehyde, secondary alcohol will give you ketone. Reduction is a reversal. So when I reduce my aldehyde, I'm going to give my alcohol. When I reduce my ketone, I'm going to give my secondary alcohol. So what can I use to reduce? I can use my hydrogen and nickel. Remember, in your hydrocarbons, you're told that whenever I want to hydrogenate, I can use my hydrogen and nickel, hydrogen in platinum, or hydrogen in palladium. So hydrogenation is a reductive reaction because I am adding hydrogen. So the same way, whenever I want to form my alcohol from aldehyde, I am hydrogenating because a reductive reaction. So I can use the same reagent I use for my hydrogenation for my reduction of aldehyde to alcohol. Okay, I can also use lithium aluminum tetrahydride. So this can be used for my, I can also use sodium borohydride. Now, look at the two reagents. Now, the first one, because I'm hydrogenating, because I'm using my hydrogen and nickel, hydrogen and palladium, I am going to reduce both the double bond and use my primary primary when I'm using lithium the double bond is not affected. At the reagents, look at the reactant double bond to be affected. So I cannot use hydrogen. Confirm that both hydrogen being changed out. Reduction, the clemency reduction. Somebody saying I cannot hear. You're supposed to hear. Clemency reduction. Now, when you're talking about clemency reduction, it is very, very important. It's when I'm reducing my benzaldehyde. Who else is not hearing me? Who else is not hearing me?
We can hear you now, ma.
We can hear you now.
Okay.
We can hear you now, ma.
Now, clemency reduction is very, very important. Very, very important. Please, whenever I'm talking about clemency reduction, I'm talking about from methanol. Okay? That's from benzaldehyde, I'm forming a toluene. From my benzaldehyde, I'm forming toluene. So what do I need? I'm going to use amalgamated zinc in ConKCl. Please, if you can forget, just make sure you're conversant with this reaction. Zinc in mercury, they call it amalgamated zinc, okay? Then in ConKCl, what it's going to do is going to take out the carbonate, and I'm going to form a methyl. So from my benzaldehyde to form a toluene, what I need is what? Clemency reduction. In this reduction is addition of hydrogen or removal of oxygen. So in this reduction, oxygen was removed and hydrogen was added to form our toluene. So we'll talk about reduction of alcohol, that whenever you want to reduce your aldehyde and you want to hydrogenate, there is a double bond, and that double bond needs to be change to single bond. So I'm not going to use normal or reducing agent like lithium, aluminum hydride, or sodium borohydride. Okay, because those ones are doing selective reduction. So if I want to do complete reduction, I have to hydrogenate. Hydrogen in nickel, hydrogen in platinum, hydrogen in palladium. But when I want to hydrogenate without tampering with the double bond, I can use lithium aluminum tetrahydride, okay, or sodium borohydride. So they're not going to tamper with my double bond. Very, very important. Then we'll talk about the clemency reduction. So the final one we need to talk about is this reaction happens in the lab, carbonite. If you're in the lab and you're given a carbonite compound, for you to do the reaction of haloform or iodoform, it means that this carbonite will have a methyl. Okay, it must have methyl, meaning that methanol cannot undergo that. Okay, then ethanol can do that. Propanol cannot do that because propanol does not have terminal methyl. In ethanol, in aldehyde, it's only ethanol that has terminal methyl. Okay, so for the only aldehyde that can undergo haloform or iodoform reaction is ethanol. But other ketones, so whenever you're giving reactions or compound, I say which of the following cannot undergo haloform or iodoform reaction? Remember, haloform and iodoform are the same. So look at the carbon, number one, they must be, look at the carbonite compound. Now, not only carbonite compound, remember they are product of oxidation of alcohol. Now, if my ethanol can do that, my ethanol can do that too. So any of the alcohol that cannot do that, any of the aldehyde that cannot do that, its alcohol cannot also do it. So because propanol cannot do that, remember my propanol does not contain methyl as terminal. It's only ethanol that contains methyl as terminal. But also every secondary alcohol that can form a ketone, remember ketone has terminal methyl. So ketones, all ketones that have terminal methyl can undergo haloform. But the only alcohol or aldehyde that can undergo haloform is only ethanol. Go back, there are some questions that you can see this question. I don't know how you solve it, the way you solve. So go back there with this class and go and solve this question. And what is going to form is what? A yellow crystal called triiodomethane. This is a common question you will always expect. So go back and look at it very well. Triiodomethane is the yellow crystal. So when you go to the lab, they're going to give you a compound. They want to tell you, whenever you're giving a compound for you to do iodoform reaction, it means that the ethanol you're dealing with, it should be the aldehyde you're dealing with might be ethanol if it's aldehyde. So if there's no yellow crystal, you know that it is not aldehyde. So if there's yellow crystal and you confirm that your carbonite compound is aldehyde, so you know that the nature of this carbonite compound is ethanol. Okay, so it's screen this unknown aldehyde from others. It's only ethanol that can be positive with iodoform reaction. All other ketone that has terminal methyl can be positive with iodoform. So the characteristics of iodoform reaction is the carbonite must be attached with terminal methyl. Please go back and solve this question. And the product is yellow crystal, which is triiodomethane. So any question? This is the end of my class. So ask question on this. Please go back to your past questions. And if you have anything you've seen in past question you don't know how to talk about, you can just share. Let's use the remaining minutes and sort it out. And if you have any question in what we've said so far in this carbonite compound, I don't want you to fail any question in carbonite compound. So anything you don't understand on the carbonite compound, let's sort it out now. You should know the difference between Aldol, cross Aldol, Cannizarro, cross Cannizarro. You should know the difference between them. And all these reactions should not be different between them, as I've explained. Go back and go through them again. I also talked about ammonia derivative when you're using hydroxylamine, you form oxime. Whenever you're using phenylhydroxine, you form phenylhydrazone. And I told you that phenylhydrazine is that Brady reagent that used to confirm the presence of carbonyl compound, giving you a yellow or orange crystal. I also told you about hydrazine will give you hydrazone. Also know the formula of this reagent is very, very important. Okay, because it will, and I'm talking about this cyanohydrin. So I'm talking about cyanohydrin, how you're going to form any product whenever you're dealing with carbonyl compound. Just break the bond that connect oxygen and carbon. So put positive on carbon, negative on oxygen. So whatever you want to add to them, break them into electrophilic and nucleophilic, unlike will bond, and you form your product. Okay. So let me ask your question. If you want to ask question, I can raise up my hand so I can give you opportunity. Okay, somebody, Victor or Guinea. Sorry if I did not pronounce your name well. Okay, let's hear you, Victor.
Good morning, ma.
Yeah, blessed
Hello,
morning.
ma. Good morning, ma.
Yeah, good morning.
Can you hear me, ma?
I can hear
Okay,
you
ma.
very well.
I have a question. Like,
Okay.
you said that tertiary alcohol, you know
Yeah.
that it cannot undergo oxidation
Go.
reaction,
Yes.
but like, can't it still like in while I was reading through it, like they said it can go oxidative degradation when
Yes. Now,
you oxidize it in some condition under some specific.
now when something is degraded, what happens? What do you understand by the word? It's
It is
destroyed.
broken down.
So yes, it's broken down. So that's degradation. So it's not a reaction. Whenever you're doing something and you're cooking and they say this food has burnt, it's a reaction. But is it profitable? No, that's degradation. Okay. So whenever you force it under some condition, it's going to be degraded. So that's not a positive reaction. So in the exam hall, please, tertiary oxidation is stable to oxidation. Tertiary alcohol is stable to oxidation. Remember, it's saturated with methyl, right? So all the methyls are saturated already. So there's no place the reaction can occur. Why primary and secondary, they have hydrogen. Okay, the higher the hydrogen, the more the propensity of oxidation. So that's why primary alcohol can oxidize further. Why ketone from secondary alcohol cannot oxidize. If you force it, it's going to cleave and form acids.
Okay.
Are you
I have
fine?
another question.
Okay.
Okay, ma. In that condensation reaction of carbonyls with amines. Now, what if it reacts with either a secondary tertiary amine? Will the reaction go through?
Now, remember what you're looking
Hello,
at. Hello, can you hear me? Can you hear me?
Yes, ma. Yes, ma.
Now, the only ammonia derivative, because in this condensation reaction, we need 2 hydrogen from my ammonia derivative, right? So any ammonia derivative that cannot give me 2 hydrogen because I need to eliminate water. So where will I get the hydrogen to eliminate water from? And so that's why they gave you some examples of ammonia derivative that you can actually use in this condensation reaction.
Okay, ma.
Do you understand? Because I need 2 hydrogen from the ammonia derivative. Then to eliminate water so that the oxygen from carbonyl can go and they go out as water. So whenever you're looking at compound that can undergo this condensation reaction, look at the product I want to form and how to form it. That's why I'm teaching you how to get the products. So it's going to give you idea of what is not workable.
Okay, ma.
Right.
Okay,
Chine, welcome. Another question.
Ma, please, last one.
Okay.
Yes, ma. Okay, ma. This one is in the preparation of carbonyl by the reduction of acrylamide with lithium, aluminum, hydrogen,
Okay.
tritertiary butazide. Now,
Okay.
when you is it only aldehyde that is the compound form,
Now,
or can ketones be formed as well?
now, in ketone, remember we're talking about acid chloride. Now, in this acid chloride, this is acid chloride is formed when carboxylic acid reacts with HCl or pentachloride. In your alcohol, how is acid chloride formed? Do you understand? This is a chloride of acid.
Yes, ma'am.
You cannot form acid chloride with ketone because ketone has
Okay.
terminal methyl. Do you understand?
Yes, ma'am.
Yes. So that's why we call it acid chloride. It's not just aldehyde. So that I'm forming aldehyde using acid chloride. So at the end, what am I doing? I'm going to exchange this chlorine with hydrogen. So remember, a reduction is addition of hydrogen. If I add hydrogen to my reduction, I'm not going to form a ketone, am I?
No, no, no.
Okay, so that's why ketone cannot do. So you're welcome. Which other question? Who else have question? Salami Solomon, your time.
Okay, good morning, ma.
Good morning.
Okay, ma, I would love if you can help me differentiate between the Haloform reaction of carbonyl groups and the Haloform reaction of alcohol.
Now, okay. Now, remember, carbonyls are product of alcohols, right? I want you to answer me, the one you know. Do you know that carbonyls are product of oxidation of alcohol, right?
Yes.
Now, and I said that for any compound to undergo haloform, it must have methyl, terminal methyl connected to the carbonyl. Now, if you look at methanol, right? When you oxidize methanol, you're going to form methanol, and that methanol does not have terminal methyl. Now, whenever you want to see any compound that will undergo haloform, whether in alcohol or carbonyl form, when you draw the structure, make sure that the carbonyl compound is directly linked to methyl, not ethyl, not propyl. So any alcohol that can give you that structure can only be ethanol. Because propanol, when you oxidize it, is going to form propanol. And that propanol is going to have ethyl, not methyl. So any other alcohol can never, when oxidized. Then if you go to secondary, I'm talking about primary now. If you go to secondary alcohol, now any secondary alcohol that can have methyl, it means that I can have two. If I have butan 2-ol, butan 2-ol, when I oxidize this, I'm going to also have a terminal methyl because it's 2, meaning that my methyl, I can still have methyl. So whenever you want to draw a structure of or whatever you did, so that my ketone functional group will be attached directly to methyl, or my aldehyde functional group will be connected to methyl. So methyl is the cocoa. So any alcohol that when oxidized is going to give us a terminal methyl, whether secondary or primary, can undergo haloform or iodoform reaction.
Okay, ma. Thank you, ma.
Do you understand that?
Yes, ma.
Are you sure you understand it very well?
Not really sure. I'll still have to just look into it and get better.
Okay, look at what I'm saying now. Do you know what is, whenever I oxidize alcohol, I'm going to form aldehyde, right? Or ketone, right?
Yes. Yes.
Now, if you draw the structure of your compound, you know the structure of methyl, right?
Yes, methyl.
Methyl is CH3.
Yes.
So any compound that will undergo haloform must have CH3 attached to CO carbonyl.
Okay.
Do you understand? Now, primary alcohols, we have methanol, we have ethanol, we have propanol. Why methanol and propanol cannot undergo? Because when you oxidize your methanol, you're going to have CHCO as the aldehyde. Does it have methyl connected to carbonyl?
No.
Then when I oxidize my propanol, okay, at the end I'm going to have CH3, CH2 connected to carbonyl Is it methyl?
No.
Now, when I oxidize my ethanol, I'm going to have CH3CHO. Is it methyl?
Yes.
So that is why it is only ethanol for primary alcohol that can undergo. Then when you go to secondary alcohol, remember my secondary alcohol, the carbon that bear hydroxy must have only one hydrogen. Then consider the position of this hydroxy group, because that's what determines the position of the ketone. If at the end of oxidation, my ketone is going to have methyl, either by the left or by the right, that must be terminal methyl.
Okay.
So which means my propanol must undergo, because it has methyl by the right and left, right?
Yeah.
So when you have your alcohol, just what you're going to do, this is my secondary alcohol, remove that oxygen, that hydroxy group, form a ketone, and look at what is by the side. Is it methyl by the left or right? If there is no methyl alcohol, it cannot undergo. But if there is methyl either by the left or the right, it will undergo. That's for ketone. But for aldehyde, okay, and primary alcohol, is only ethanol that can undergo that.
Okay, man. Thank you, man. Thank you.
Right. Any other question? Before? Okay. Is it Osheni? Osheni, hurry up.
Ma, good morning, ma.
Good morning. Ask a question.
Okay, ma.
Okay.
Hello, ma.
Do you want to share? Do you want to share slide? Do you want to share something? I want to ask questions.
Is the network? Yeah, network is shaking. Okay, ma. Ma, you said reaction with greenhouse reagents, the primary alcohol give birth to methanol. The secondary alcohol.
I say when you're preparing alcohol using greener reagent and carbonyl compounds,
okay,
you're moving from aldehyde to alcohol, right?
Okay.
Using greener reagent. Remember, some of these under normal reduction you can get it, but if the question is using greener reagents, now
yes,
what greener reagent is going to do is going to increase the number of carbon atoms. Okay, in your aldehyde. Okay, if I'm using if I want to form primary alcohol, the only greener reagent I need is methanol. Other aldehydes is going to form secondary alcohol. So from ethanol to whatever is going to form secondary alcohol. And if my target is for me to form tertiary alcohol, I don't need aldehyde. What I need is ketone.
Okay, ma.
So the question can be, which of the following can form primary alcohol? Go and look for methanol. And if you say which of the following can form secondary alcohol, go and look for any aldehyde. Except they tell you the number, they tell you, okay, which of the following can form, let's say, butan 3 or butan 2 ol. Which is what? Now, butan 2 ol is secondary, right? So you go and look for, it means you're looking for any aldehyde. The question would determine the answer. If the question you're asking, if the structure they gave you is primary alcohol, go and look for methanol with greener reagent. Remember, with greener reagent. If the question is secondary alcohol, go and look for any aldehyde. Before all tertiary alcohols is ketone with greener reagents.
Okay, ma. Okay, ma. Thank you.
Omolabo Oludere, the last on the list. Please ask your question. The time is up.
Sorry, ma, for you.
How are you? Good morning.
I wanted to ask concerning this oxidation of aldehyde and alcohols. There was a part that if you react primary alcohols with particular reagents, I don't really know the reagent. It's to further give you carboxylic acid. Please, can you explain it?
Yes. I said, whenever you're doing oxidation of alcohols, primary alcohols, when you oxidize them with normal oxidizing agents, permanganate or chromic acid. Chromic acid can be potassium heptaoxodichromate or sodium heptaoxodichromate in sulfuric acid. Okay?
Yes,
if they are the reagents, what is most appropriate is carboxylic acid.
Okay. Okay, if that reagent.
Okay. If that's the reagent, they gave you a primary alcohol, and these are the reagent they gave you. Say, please, what's the products? If these are the other reagent they gave you, permanganate or chromic acid. Chromic acid can be in potassium or in sodium. So you're going to form carboxylic acid. But if the question is PCC,
Okay.
no, the answer is aldehyde because it's limited oxidation.
Okay, ma.
So other reagents undergo unlimited oxidation that must form an acid for primary. But remember, all secondary alcohols end in ketone.
Yes, ma.
Okay. So when they oxidize further, they will be cleaved to form acids. They will break down because they are stable to further oxidation. Okay.
Okay, ma. Thank you.
Any other question? Do you understand that again?
Yes, ma. I'm fine. Thank you.
Is that clear? You're fine. Okay. Any other
Yes.
question before we end it here? Please, I want you to read for
Please,
your
ma,
test.
I need to
Okay.
send
And
the
if you have any question, I'll ask them if I should send to you. Then, if I'm permitted, I'll share it on the group. Okay. I'll ask the coordinator.
Okay, ma.
But remember, I can always go back to the YouTube and look at whatever. And I have a YouTube channel where I teach all those topics, so you can also go and listen to them. Okay.
Okay, ma.
All right.
Please, ma, can you open the group chat so we can send questions later on today?
Okay, I will do.
Thank you, ma.
I will do. But
Thank you, ma.
whenever a question is
Thank you, ma.
asked, please allow the question to be sorted before dropping another. And
Okay.
Ma,
there should not be
are you going to give us some past questions?
I was thinking that might be a time for us to review past questions, but I don't know whether it's possible. But I will speak with the coordinator and see if it's possible, if it's a workable thing. Then I will get back to it. But that might be after the test. But if I have
But
any time on Wednesday before the test on Thursday, I will also come. It's
okay,
depending on
thank
my
you.
schedule.
Ma, the
But
test
just
is
read and ask the
exactly by
question.
8 o'clock.
Sorry?
The test is exactly by 8 o'clock. Or
We
on
don't
that
know
day.
yet. You'll be communicated. Don't be afraid. The time we should be, it might not be 10. It might not be 8. We might make it to be flexible for 10 so that nobody will give excuse. But I don't know yet. To be communicated. Okay?
All right, ma'am.
So read.
It on your aspect and other lecturer aspect, or just only your aspects?
No, everyone. They're going to do. We're just preparing you for exam. So whenever you read as if you're writing the exam. Do you understand? It's just like preparing you for exam. So you have to read everything. So it will come from anywhere, from my section and from it. That's why what I treated today is not my section. Okay. So, and I will also want you guys to drop on the group the topics you want to be revised, because there'll be another revision on Monday. There'll be another revision on Tuesday. So drop the topics that you know that you need. So majority will carry the vote so they can know the topics we have to revise for you. Okay.
Okay, thank you, ma. Please, what about us that are not on the group chat?
Everybody's supposed to be on the group chat. What happened?
I'm not on the group chat though. I think I tried to join once and it said it was full. So I don't know.
You would have commented, you would have talked to someone so that we can create another group chat, because group chat is important for dissemination of information. So if you're not in that, you will not get information. It's not good for you. So if you know that you have issue joining the group chat, talk to your course rep, let your course rep chat me up. So let's see if we can create another group chat so that everybody will be on the same page. Okay? So you can get the information you need when you need it.
Yes, ma. Thank you, ma.
All right. Okay. Thank you, everyone. I wish you the best. Remember, don't be afraid of chemistry. Okay? You can make your A. Some people last year some people were having 98 over 100. So if somebody can do it, you can do it better too. So don't be afraid. So when any topic you don't understand, and check my YouTube, Dr. Anita came, you can go there and listen to the audio lecture. Also ask your question, you'll be responded to. Success, and see you next week.
Thank you, ma.
Thank you, ma.
Bye.
Thank you, ma.
Yes, you can do it better. Yes. Anybody that will have 95, I'm going to give the person gifts. 95. So I'm challenging you. Go and read. Bye for now.
Mark, next week Thursday is our test, right?
Sorry?
Okay, ma. Next week Thursday.
Yes, it's a test. And you'll be communicating on the